Alright, so it's 4-2 day. I'm going to grade the 4-2 quizzes. So what we'll do to get ready for to teach you 4-2 and get ready for 4-4, you've got a study paper to help you with 4-4. So the homework tonight's off of 87. The syllabus can get you the numbers of what to do on 87. In terms of your read, 4-4 is going to have 7 fill-in points. And I think yesterday we sort of learned to some degree, hopefully, what that means when I say there's 7 fill-in points and you know what you're looking for. And I'm not going to drop you a better hint than that on what the 7 fill-in points are about. Let's fill some of this in just sort of in random order. So today there were 4 postulates, and I couldn't have emphasized more often yesterday or other days. You have to know the names of the postulates. So as you read and there's a postulate, you have to know the names. So somebody, a recollection of a name of a postulate today. What was a postulate in your reading?
Angle measurement.
There was an angle measurement postulate. So I'm going to abbreviate that AMP for angle measurement postulate. And you'll do that on 4-4 the same way that you did it today. So here we go to 19 to fill that in. Can anybody tell me what the angle measurement postulate says? That was one of the 2 that I said you just have to do the sentence. Correct. And I don't care if you even give that angle that name. You could just say for every angle, there corresponds a real number between 0 and 180. So angles get numbers. We're at a point of the year where you can start to compare things we're learning now to things we've learned before. There's starting to be some links and some similarities and some differences. So what that maybe could remind you of, and I'll clue you in if it didn't, that kind of might remind you of the distance postulate. Can anybody still do the distance postulate? Correct. Okay, distance postulate just used to say if you had 2 points, we could give a number to that. So here's a point, there's a point, there's some number that can represent that, and that number was called the, could be length, distance, more likely called distance. The distance postulate gave us a number, and we called that the distance between the 2 points. Angles, we can do the same kind of thing. If I draw you an angle, we could break out our tool. Anybody from younger days, what's the tool called that can measure angles and give them numbers?
Protractor.
Protractor. So we can have an angle, we could measure that, and angles can be given numbers. What do you think that number is called? The measure. So the angle measurement postulate gives you a thing called the measure, just like the distance postulate gave you a thing called the distance. Points can be given numbers for how far apart they are. Angles can be given measurements like, protractors give numbers. So we just were able to maybe answer number 20. Today you should have filled in the blank with measure at some point, because measure was one of those blue italic words that was in there. That was a quiz answer today. For number 20, when we go backward next quiz, you just need to say it's the number given by the angle measurement postulate. And you don't have to write out angle measurement postulate. You can use my abbreviation if you like AMP better. I sure like letters better than big words. But 20 on next quiz, it's the number that gets given to you by the angle measurement postulate. Question about that sort of comparison? If we're going to do our abbreviations, like I call this A, if I got my protractor out and that was like 40 degrees, I could say to you the measure of angle A equals 40. That would be a way with symbols I can communicate to you that idea without having to use a lot of words. When you see the little M's on your homework life, that's just referring to the measures. Somebody give me another postulate. There were 4 of them, there's 1 down, 3 to go. There is an angle addition postulate. So the angle addition postulate, I did not have you write out the sentence for that. You just had to fill in the blank with the angle addition postulate. But if you look at number 22, you see that tomorrow that goes the other way. So we're going to practice that a couple times. So here I go this way. So here's the angle addition postulate the way it appeared on your quiz. is if D is in the interior of angle BAC, then the measure of angle BAC equal measure of angle BAD plus measure of angle CAD. I would not suggest you try to memorize all those letters. What I would suggest you do is try to draw a picture and then just work it through. If this angle is BAC, what might I put here?
B.
B. What do I have to put here?
A.
A. Who else could I have put there?
C.
C. B and C are interchangeable. Where should I put the D?
In the middle.
Somewhere in the middle, and make another angle out of it. So if D is in the interior of angle BAC, then angle BAC is the big boy that ate everybody else. That would have to equal the measure of the upstairs plus the measure of the downstairs. In the homework, this might appear to you like they say this is 10 and this is 20, and they expect you to tell them that the big thing is 30. Or they might tell you that the big thing is 70 and the upstairs is 40. Then the downstairs is 30. That's just how that has to sort of like function. Question about that concept? So here's what I would suggest is if you're doing this on a quiz, these letters don't matter. But the structure of the sentence does. So if I'm going to do the angle addition postulate, I'm just going to go like this on my page. And then I'm going to pick 4 different letters. D, A, V, D, go, K. No good name, 4 letters, all different. So if I want to do that off of that picture, who's in the interior? V. Of the angle, who's the big one?
DAE.
Then,
Angle DAE.
big one again, equals
DAB.
top part plus
DAE.
bottom part. I'd memorize the picture and then like make it up. I wouldn't try to memorize the letters. Question about what happened there? Let's go again. Why would Emma's name not work well with this?
Because she has 2 M's.
She has the repeat letters, so that shorts us. So W, E, N, G. We can spell some names. Use your names. You got 4 different letters. So we'd say if N is in the interior of angle
WEG.
WEG, then
WEN.
equals
WEN. NEG.
agreed. I could practice that some more if you want, but that's what we're trying to do tomorrow. Monday is actually tomorrow. 22, just do something like that. Question about that one. Comparison, I would say the angle addition postulate compares to the definition of between. So if we think back to our memory banks, can anybody still do the definition of between?
A, B, and C are all collinear.
That's true.
AB plus BC equals AC.
Agreed. Now, you could memorize all those letters. I, again, wouldn't. I would do the definition of between generally from a picture. If I want to draw B is between A and C, this would be A, this would be
C.
C. Should I put the B right here, exactly in the middle?
No.
Could I?
Yeah.
Yeah, just the B is anywhere along the road. Definition of between is based on like a segment that got kind of cut up. There's a little piece plus another little piece, and if you add up the 2 littles, it equals the big. That's exactly what angle addition postulate did. You had an angle, you cut it in pieces, there's a little piece plus a little piece has to make the big thing. Definition of between. It's little plus little makes big. I wouldn't memorize the letters. You can if you want to, but definition between, I like think through picture style. Angle addition postulate, I'm thinking through picture style. But just like definition between lets you add littles to make a big, so does the angle addition postulate let you add some littles and make a big. Question about angle addition postulate? There's 2 postulates down, 2 to go. Another postulate. Supplement postulate was in there. So supplement postulate, today you did the sentence, next time you'll do the same sentence. So supplement postulate says, if 2 angles form a linear pair, and I'm on 26 here, if 2 angles form a linear pair, then they're supplementary. If 2 angles form a linear pair, then they're supplementary. So let's explain linear pair before we try to explain that one, because that's based on another thing. Linear pair was another one of those italic blue things that we had a definition for that somewhere on your quiz would have filled in the blank. This is what the quiz said. Definition of linear pair said ray AB and ray AD were opposite rays. What's it going to look like if I draw some opposite rays?
A ray pointing to the other side.
Yeah, and if I put them together, what's it going to look like?
A line.
A line. This would be ray AB being an opposite ray to ray AD. We step in, AC is any other ray. So here goes an AC is any other ray. Then I just made 2 angles. I made an angle BAC. I made an angle CAD. Those 2 angles together are a thing that's called a linear pair. Does it seem like it'd be hard to memorize all those letters? I would think so. So don't try to memorize the letters. Try to work from a picture. If we want to draw a linear pair, draw a line, and then splice another piece off of it. LP is our abbreviation for linear pair. So we need 4 letters again.
William.
Yeah, we can use that. That'll work. Crash.
Or not.
Any 4 letters will do the trick.
Got it.
So who are our opposite rays?
AI.
AI is 1. AM is 1. AI and AM are opposite rays. Who's the other ray?
AL.
AL. They all have to start with A because A is where everything is touching. Then what angles are the 2 angle names that form the linear pair?
IAL.
IAL,
LAN.
LAN. You do that again if that'll help people. Might as well do 2. You're going to have to say this and that are opposite rays. This is some other ray. Name the angles you formed, make a linear pair, but it doesn't matter what letters you pick. Chalk is fading hard. Use your last name. What are all the rays going to start with now?
L.
L. Since L is the center where all the action happens, the opposite rays are
Y.
LY and LE. The other ray, LK. The angle names,
YLK.
YLK
KLE.
and KLE. Question about linear pair action. Okay, then to make more sense out of the supplement postulate, we need to talk about supplementary. Supplementary was another one of those blue italic words. There was one that said supplement, there was one that said supplementary. What was the key to supplement or supplementary? Magic number. 180. So the 25's answer is that the measures add up to 180. measures add up to 180. So, if you see a thing like this, that's called a linear pair. If it's a linear pair, it has to be if two angles form a linear pair, then they're supplementary. Supplementary means add up to 180. So maybe this is 100. Who's this? 80. So I draw you that. That's called a linear pair. And if two angles form a linear pair, then they're we know it, somebody say it. We'll read it from number 26. If two angles form a linear pair, then they're supplementary. Supplementary means that together they make 180. So let's say this is 50. What's that? 130. So one more time. I just drew you a linear pair. And if they form a linear pair, then they're supplementary. Supplementary means together they make 180. So if that's 90, that's also 90. That shouldn't be earth-shaking. That's just, it just is. It's a postulate. It's not like, wow, my life has changed forever. There's a fourth postulate. Angle construction postulate. Angle construction postulate, I'm not going to make you do it out on this or any future thing ever. We'll just fill in the blank on 21 with the angle construction postulate. The angle construction postulate's a lot like the point plotting theorem. The point plotting theorem basically said if we have a number line and we want to go in a certain direction, we can do it. Like, here's a point, I want to be 6 squares away from that. I could find a thing 6 squares away if I went right. I could find another one 6 squares away if I went left. But once I commit to going in a direction, I'm only going to find one more point that's a certain distance away. You always filled in the blank with point plotting theorem. We never said that out. We never will. Angle construction postulate is similar. If I say I drew you a ray, I want to make a 30-degree angle. Where's one way I could draw myself a 30-degree angle? If I drew up, I could make a 30-degree angle in that half of a plane, or I could just as well have gone down. I have two options, one in each half of the plane that's out there. That's not nearly as important as the other stuff we did. If I had to pick a few that are more important than what we just filled in, 26 is a big deal, 25 is a big deal. Linear pair is a big deal. Angle addition postulate's a big deal. Like from 22 and down, that stuff that's going to be around for a while. 21, 19, that is not as important of a thing. Okay, but today's things, we were seeking to understand the 4 postulates that we said, and then the 3 italic-y blue words were supplementary, measure, and what was our other one? Linear pair. That's what hopefully you had filled in on there. Question about the new stuff that we've gone through. I think everything new on the board. That's like what the homework is going to tend to do. Something on that. Okay, some of the other questions changed, so if you see something that's unfamiliar, let's hit that up. So some of the stuff here from 8 through 18 is different, but some of that's the same format that it was in before. Some of them I just changed the letters is all that I did. Anybody 8 to 18, something you want to know about? 13 you would just make a list with W, X, and Y, yes. Let's do 8. 8's different. 8 you did today with a series of 4 blanks. Can anybody do the 8 without the blanks to guide you? Can anybody get the first word that was the first blank for
Union.
angle? Union of what kind of stuff makes up an angle?
Two rays.
Two rays, and they have to have two like facts about them. Have a common endpoint and be non-collinear. Order not super important there, but so you could say if you want the shortest answer possible, I'd probably say union of two non-collinear rays that intersect only at their endpoint. You probably can't go shorter than that. Union of two non-collinear rays that intersect only at their endpoint. So let's do 12. 12 is almost the same as 8. What change do you have to make on triangle? Three segments. And other than that, we should be good. Union of three non-collinear segments that intersect only at their endpoints. That can win for 12, just like we had for 8. Anything else you want me to help you tune up on the, well, anything really. Anything I can help you to do to have a more effective study sheet than we have at present?
What was 11?
11 would be the exterior. I usually day by day wiggle between doing interior and exterior, but it's sort of a giveaway when I do exterior because it says at the last phrase it's not in the interior. So if it's, you know, if I say in the final phrase it's not the interior, it must be the day for exterior and vice versa. More stuff, anything I can do to help the study paper 4-4? Oh, let's go quickly to page 80. Did anybody have anything on page 80? We can't do every answer right now, but we could do some stuff. Did anybody have on page 80 anything that you, as you were doing it, went, don't understand that question? Anybody, page 80, anything that was an uh-oh moment? Fantastic idea as you do your homework, if you have an uh-oh moment, would be to write a note to yourself, like up at the top, ask about 10, uh-oh.
17.
17. So 17, they say, if we draw an angle in a plane, you never have to worry about drawing a plane. Why in class or at home do you not have to actually worry about drawing a plane? Well, I skipped a couple here, I'll come back to this. Why don't I need to worry about drawing a plane? Your paper is a plane. And in my classroom, the board is a plane. So I'm going to draw an angle on my plane, or your plane. It asks, how many sets did we just separate life into? Two. This one's called the interior. This is called the exterior. Then they asked us to use an old word. How many of those two are convex? If I like shade this all in, is that convex?
Yes.
Yes. If I picked any 2 points in there, I have to stay in there. If I just focused on the exterior, is that convex? No, because if I pick points like this, I'd have to like leave the zone and come back in. So 2 sets, 1 convex. Does that work for you?
Yeah.
Okay. Here's something I forgot to do. If I asked you to come up with the supplement of 100, we sort of did that in picture form, but in word form. What would the supplement of 100 be? 80. Because those two numbers make 180. Supplement of 60 is 120. Supplement another voice of 178 is 2. A different voice supplement of 5, 175. What math are we doing there? Probably not to come up with the missing number. You probably subtracted. So what if I asked you, I gave you an x? You would go 180 minus x. The way you're doing this math to find the supplement is 180 minus whatever I happen to give you or what the book happens to give you.